In this video, I'm going to talk about solving trig equations, but it's going to be really basic. So a trig equation looks something like the following. It could be, say, like 2 sine of x plus 1 equals 0. Excuse me, it could be 3 tangent of x minus rad 3 equals 0. You could even do all kinds of crazy things, like, I don't know, 2 cosine squared of x minus 1 equals 0. So the reason they're called trig equations is because you have a trig function in the equation. You could even have multiple trig functions in an equation, but this is just going to be a basic video. And our goal is to solve for x. And so what you need to understand is that our answer or answers are going to be represented as angles, right? So I'm using basic ones that are going to have angles that end up on the unit circle. So if we just quickly draw a picture of the unit circle, here's your unit circle, okay? Right, so all our angles are going to start at 0. And here's pi over 2, there's pi, 3 pi over 2, and then all the way around would be 2 pi. We're looking for the angles that would make these equations true, right? So might be pi 6. And hopefully you have some introduction to trigonometry prior to watching this video. Pi 4ths, pi 3rds, right? Or 30 degrees, 45 degrees, and 60 degrees. Whoa. Right, so our answers are going to be in the form of these angles all throughout the unit circle. We also would have 2 pi 3rds, 3 pi 4ths, 5 pi 6. I'll label just the radians because I'm going to stay in radians for the most part. And your answer is just going to be the angles that make these equations true. So these are going to be our answers. So hopefully you kind of get where we're going with this. I'll finish. So 7 pi over 6, 5 pi over 4, and then 4 pi over 3, 5 pi over 3, 7 pi over 4, and 11 pi over 6. So any angle that's written here could potentially be an answer to the equations that I'm going to solve, right? A couple other things about trig. Remember that, let's just take this one for example, since it's not in the way. The way I would solve this is I'm going to get the trig ratio by itself, or the trig equation. I'm going to get the trig function by itself. So I have 2 sine of x plus 1 equals 0, and I would subtract 1. So 2 sine of x equals negative 1. Then I'm going to divide by 2, and then I'll get sine of x equals negative 1/2. So we're looking for two things. We're looking for two angles, because I know that sine is negative in quadrants 3 and quadrants 4. And so in quadrants 3 and 4, there are going to be an angle that makes sine negative 1/2. So if you have your things memorized, sine is negative or 1/2 at pi over 6. And so in quadrant 3, that would be 7 pi over 6 and 11 pi over 6. So I'm going to say that x equals 7 pi over 6 and 11 pi over 6. And you know, people ask me, well, how did you know that? How did you know those angles? Part of this is memorizing, right? So I've memorized that on the unit circle, this point here is rad 3 over 2, comma 1/2. The x value represents the cosine, and the y value on the unit circle represents the sine. And so rad 3 over 2 would be the cosine, and sine is 1/2 for pi over 6. So I just need it to be in third and fourth quadrant so that the sine is negative, because sine relates to the y value. So that would be 7 pi over 6 and 11 pi over 6. Okay? we're going to keep solving equations, but that's the gist of what we're trying to do. In my class, I go over problems with two different types of instructions. So the first one is find all solutions in the interval, and then I give the students an interval that the angles have to be in. So the most common one I use is 0 to 2 pi. And so that would be the image I drew up here, right? So 0 starts you here and goes all the way around to 2 pi. So I'm saying find any angle in that interval, 0 to 2 pi, that would make the equation true. And then I just solve them. So I'll just use the ones that were up above that we didn't solve. So for the first one, we'll call this example A. We've got 3 tangent of x minus rad 3 equals 0. So in order to solve this again, I'm going to get the trig part alone. So then I'll have 3 tangent of x equals rad 3. I'll add the rad 3 over to the other side. Then I'll divide by 3. And I'm doing all this so that we don't need a calculator, and we should be able to just use our understanding of the unit circle to find this. So when I'm looking at this, it says tangent of x equals rad 3 over 3. I say to myself, where is tangent going to be positive? So I need to know that. That's in quadrant 1 and quadrant 3. The second thing I need to know is, when is tangent rad 3 over 3? And again, that would be at pi over 6. So in quadrant 1, my angle in quadrant 1 is pi over 6. And my angle in quadrant 3, if you go back to the unit circle, right, my angle in quadrant 3 that has a reference angle of pi over 6 is this again, 7 pi over 6. And so I have two answers in the interval of 0 to 2 pi of pi over 6 and 7 pi over 6. Let's do the other one. We've got 2 cosine squared of x minus 1 equals 0. So 2 cosine squared of x minus 1 equals 0. This one is quadratic, so what we're going to have to do is we're probably going to have to square root at some point. But the good thing to do first is to get the cosine squared alone. And so we'd add 1. So 2 cosine, wow, my pen is really off. 2 cosine squared of x equals 1. We'll divide by 2. Cosine squared of x equals 1 over 2. Then we're going to square root. And remember, anytime you square root in an equation, you're going to need to equal plus or minus. And the way you square a fraction is you square at the top, square to 1, square at the bottom, square to 2. So I'll have cosine of x equals plus or minus the square root of 1 over the square root of 2. And so that reduces. We'll have the cosine of x equals plus or minus the square root of 1 is 1, and the square root of 2 is square root of 2. And we're going to need to rationalize the denominator, so it will just be rad 2 over 2. So cosine of x equals plus or minus rad 2 over 2. Alright, and then you're thinking to yourself, okay, cosine is positive in quadrants 1 and 4, and cosine is negative in quadrants 2 and 3. So now you actually just got to use all 4 quadrants and find the angles where cosine is rad 2 over 2. And that would be at pi over 4. And then in quadrant 2, that would be 3 pi over 4. Quadrant 3 would be 5 pi over 4. And in quadrant 4 would be 7 pi over 4. All right? And so that's the first set of instructions, when you just have to find all solutions in the interval of 0 to 2 pi. The other set of instructions is when I just say find all solutions. And this differs because we know for a fact that you have this unit circle or the coordinate plane that obviously you can spin around, and one time around, right, from 0 to 2 pi, that's one revolution, but we could keep spinning and finding more angles. And so we know that we can actually have an infinite number of answers. So when somebody says find all solutions, period, like that, then that means we need to write an expression. So what we're going to do is we're going to write an expression an expression that actually represents all the angles, and they're actually coterminal angles. And if you don't know what that means it's say you have an angle that ends here at pi over 4. I'm just going to keep spinning around from there, and I'm going to spin around again, add a full revolution, get another angle. So it'd be like plus 2 pi, and that would be 9 pi over 4. Then if I spin around again, that'd be another one, I'd add 2 pi. So these are all coterminal angles because they just keep ending in the same spot as pi over 4, but they're different numbers. And so you get it by adding full revolutions. So we're going to write an expression that represents all coterminal angles. Right? Our answers are going to be angles. So let's make one up. Here we go. We'll just go with A equals, example A is going to be, let's go 4 cotangent of x plus 4 equals 0. Okay, so we're going to get the cotangent alone. So subtract 4, so 4 cotangent of x equals negative 4. And then cotangent of x is going to equal negative 1. So cotangent is negative in the same places as tangent. That's in quadrant 2 and in quadrant 4. Alright? And the angle that makes cotangent 1 is pi over 4. So in quadrant 2, x would be 3 pi over 4. And in quadrant 4, x would be 7 pi over 4. And to find coterminal angles, to come back over to my diagram over here, we just add 2 pi. So to find all solutions, we're actually going to say plus 2 pi, but then we're going to say n, 2 pi n, given that n is an integer. So our answer is going to be 3 pi over 4 plus 2 pi n, meaning we're going to add multiples of 2 pi, which is how you find coterminal angles in radians. And that will represent all possible angles that would make the equation true. So this is a good answer. But as time goes on, sometimes you'll come to problems like this, and this is good, but you can actually represent your answer better. So there's a better way to write your answer. And this only works sometimes, it doesn't work all the time. What I want you to draw your attention to is that 3 pi over 4 and 7 pi over 4 are nicely separated. Here's 3 pi over 4, right? 3 pi over 4 is in the second quadrant, and 7 pi over 4 is in the fourth quadrant. So when you add 2 pi, say you're starting at 3 pi over 4, when you add 2 pi, it goes all the way around, and it ends back at 2 pi. But instead of adding 2 pi to 3 pi over 4, we could add just pi and get to 7 pi over 4, because pi would be 4 over 4. And then if you add pi again to 7 pi over 4, you would go back to 3 over 4. And then this circle would keep going if all you did was add pi. And so since they're separated evenly by pi, the better way to write this would be x equals, start with 3 pi over 4, and then go plus pi n. And this would actually encompass both statements, and therefore you can write your answer as 1. So you can go either way with that. Alright, let's try another one where you have to find all solutions, and then we'll be done for the day. So let's go with 3 tangent squared, right? And then we'll say minus 3 equals 0. So we're going to get tangent squared alone by adding 3 and then dividing by 3. Tangent squared of x equals 1. We'll square root. Don't forget the plus or minus. So tangent of x equals plus or minus 1. And then we're going to say where is tangent 1 and negative 1, and that's happening in all 4 quadrants. 1 at pi over 4, 1 at 5 pi over 4, right? And 5 pi over 4. And then it'll be negative 1 at 3 pi over 4 in quadrant 2, and 7 pi over 4 in quadrant 4. So those are your 4 answers. But since you have to write it as all solutions, look at this. These are all evenly separated by the same amount. And you can see it by looking at the numerators, right? They're all separated by 2 pi over 4. And so the nice way to write this would be start at pi over 4, x equals pi over 4, plus, and then 2 pi over 4 is pi over 2, n. And that would be the nice fancy way to write that. If you wanted to write each statement as like x equals pi over 4 plus 2 pi n, 2 pi n, then you can. But rather than writing 4 statements, it's always nicer if we can consolidate and write less. But hopefully that all makes sense. Have a great day. See ya.